A very good morning, good afternoon and good evening to all my friends, participants and students for this NPTEL MOOC course, the title of which is Application of Forecasting, Regression and Time Series Models. And my good name is Raghunandan Sengupta from the IME department at IIT Kanpur. So, as all of you are aware that this course covers three main topics. Number one is forecasting, number two is regression, number three is time series. And we are in the midst and covering the concepts of regression models and concepts. We are in week 8 and this is 37th lecture. What is the coverage? Coverage for this lecture for today is examples of MLR in finance, and as you know, we had considered in the last day, which is the last lecture, model 1 corresponding to the fact that we want to find out the returns of Tata Motors depending on the fact that NSE 50 is x1, which is the first independent variable, second independent variable is rupee to US dollar, and the third independent variable is Brent crude price. Y, which is Tata Motors rate of return, is given as small r ln of P2 by P1, where you know P2 is price for day 2, P1 is price for day 1, and this price both for P1 and P2 are the closing price. Based on that, we find out x1 also, which is corresponding to NSE 50. Rupee to US dollar is given in Ps, and the last one is Brent crude price in euros. What are the information we need to calculate? The first one, as we all know, is beta hat. So, beta hat is actually the estimate of the regression coefficients. Second one is where I am putting a double tick mark is covariance of beta hat, which will give us the relationship between the regression coefficients. And the last one is S square, which is basically the error estimate. And as you know, the term which I will now mark in green is the square of the error, and the term which I will mark with a different color blue is actually n minus k, where k, as I have explained many times, is the number of independent variables which actually has an effect on the degrees of freedom loss. So, hence it becomes n minus k. We will also calculate, this is important, and we started from the last example for the multilinear regression model, R square. So, for R square we need total regression information variation, that is divided into two parts. One is which is available through the independent variable, which is SSR, and another one is not predictable because that is under the ambit of error, that is known as SSE. SS is basically sum of squares. So, SST total is given by the sum of SSE and SSR. Based on that, we find out R square and adjusted R square, which I had mentioned the last day, is based on the fact per unit what is the fact of SSE and SST, that is the ratio. Per unit means per unit of the reading number, which is dependent on n minus k and n minus 1. N minus k for SSE for error term and n minus 1 for SST total term. Now, model 2 and model 1 differs in the with respect that we have beta naught, which is the intercept. Initially in model 1 it was not there. X1, X2, X3 remains the same as just mentioned few minutes back, and the number of readings, if you remember, was 1 to n, which is 99 in number. And if you remember, the data was taken for February, March, April, May, June 2025 per day closing price. And similarly, we had the per day Indian rupees to US dollars as well as per day Brent crude price. Again, Y is Tata Motors closing price based on ln of P2 by P1. X1 is NSE 50 closing price, again based on ln of P2 by P1. X2 is Indian in INR to USD given in INR. and X3 is Brent crude price given in euros. Based on that, when we put in the model, solve it, we get the values of beta naught hat. I will just put a different color marking, green. Beta naught hat is minus 0.1994, which is the intercept. Beta 1 is plus 1.2410, beta 2 is plus 0.0031, and beta 3 is minus 0.0009. When we calculate, these are just simple calculation which we are doing, which we know what is x, we know what is y is of size n cross 1, n is 99. So, it is basically a column vector of size 99 cross 1, only one column, while x has now it has 99 number of readings and the corresponding k is now 3 plus 1, which is because now we have in x the first column as all ones depending on the constant term corresponding to beta naught, while the corresponding values of x1, x2, x3 are respectively column 2, column 3, column 4 for x, if x is the matrix, where the size of x is given by 99 cross 4, 99 rows, 4 columns. When we solve it, you have seen the equation, we get beta naught, beta 1, beta 2, beta 3, which is given as beta hat. This is again how you find out, it can be either a row or a column of size 4 cross 1 or 1 cross 4 depending how it is being nomenclatured. Covariance now actually would be of size 4 cross 4, because the 1 cross 1 element, when I am putting the green tick mark, let me change the color, when I am putting the red tick mark is basically the corresponding variance based on beta naught. Beta naught is changing, intercept can change, because this is a random variable, in the sense we are taking from the population and we want to find out the estimate. Similarly, 2, 2, 3, 3, 4, 4 are the corresponding variance for beta 1, beta 2, beta 3, and the off the diagonal element are the covariance, and it is given, and as you can easily find out, the covariance of the off the diagonal element are symmetric, like which was also evident when we did model 1. I did not point out then, but it is obvious, it will be true in this case model 2 also. Consider this one, the covariance which is in place in this covariance matrix in the place of 1, 4, 4, 1, that is between beta naught, beta 3. If I want to find out corresponding to the fact these two elements, when I am putting a violet color, the values are correspondingly minus 0.0037, in the off diagonal elements they are equal, that is the covariance existing between beta 2 and you have beta 2 and beta 3. Now, that is negative in the sense there is a negative correlation existing between the values of beta of that x values. And finally, S square, which you know is the error square divided by n minus k, k I have mentioned again, that value comes out to be, I will read it out, which is given in the third bullet point, is 0.00026674. Now, if you compare the values of beta 1, beta 2, beta 3, their hat values which you see in this slide with the corresponding values of beta 1, beta 2, beta 3 for model 1, there is not much of a difference. So, the overall coefficient corresponding to the change of y value, which is Tata Motors returns, is almost plus minus the same per unit change of x1, per unit change of x2, per unit change of x3 remains almost the same either in model 1 or model 2. So, when we put in model 2, the value which we get is Beta naught is given by minus 0.1994 plus 1.2410, which is basically beta 1 hat or beta 1. Then you have beta 2 given as plus 0.0031, which is beta 2 hat or beta 2. And finally, the last term is minus 0.0009, which is beta 3 hat or beta 3 plus epsilon, which is the error. Now, when we do the residual plots if you remember is basically from the sample the difference between yi actual value minus yi hat, the estimated value. Based on that we get the residual per reading, and if we plot the residual, we remember that we have assumed the actual error terms. Residual is basically for the sample, error is coming from the population. The residual based on the fact of assumption should have a mean value of 0 and a fixed standard deviation of sigma square, the value. And if you remember, the S square value which we have estimated would be the best estimate for sigma square. So, if you keep repeating such samples, then the averages of this S square should slowly in the limiting case be equal to sigma square of the population. I am not going to test all these things, I am just mentioning that because people who are interested may inquire that from any advanced textbook. So, I plot the residual plot for each data point, and actually which I have also shown in the last graph for model 1, I am doing it for model 2 also. If I take snapshots, the error terms are plotted normally with a fixed mean value of 0 and a variance should be fixed, because the concept of, if you remember, the ideas of autocorrelation, non-autocorrelation, then the idea of homoscedasticity, heteroscedasticity were very important for the regression point of view, and we will slowly relax them as we proceed for the time series model, because there the variance is time dependent. Variance means of the error is increasing based on the time frame. And I have also showed the panel diagram which I have drawn for 4 different types of time series in a very simple sense. One is where mean value is fixed, variance is fixed. Second case is mean value is increasing or decreasing and variance is fixed. Third case is mean value is fixed, variance is increasing, decreasing, and the fourth one, which is more practical for the time series for financial data, is mean value is increasing or decreasing, but variability is definitely increasing. So, that is where the focus for the third important topic for this course, which is time series analysis, would be mainly focusing on. Now, we go to the other problem 26. There would be many such problems, and I am trying to give you a broad idea what are the important things you need to calculate. You need to calculate what is the beta hats, what is the standard deviation of the beta hats based on which you can find out the covariance of beta, what is the best estimate of sigma square, what is R square, what is adjusted as R square. Based on that, you can have an overview, very good idea of the regression model. So, let me read problem number 26, and the information would be available in the website which you can click and find it out. We have the following data for y and x1, x2, where researchers conducted a randomized experiment on n. N means the sample size of 120 nestling swallows, the birds, to find out their breathing habits. In an underground burrow, they varied the percentage of oxygen at 4 different levels, which was 13%, 15%, 17%, 19%. They changed, and the percentage of carbon dioxide at 5 different levels. So, breathe in oxygen, breathe out carbon dioxide. So, the carbon dioxide level at 5 levels was 0%, 3%, 4.5%, 6%, 9%. So, in total you have 4 into 5, which is 20 experimental conditions, and the researchers observed the total volume of air breathed per minute for each of these 6 nestling banks swallows, and hence the data is for 5 into 4 into 6, which is 120 data points. The online data can be accessed here, which is Pennsylvania State University, the statistics department, and you can click there and get all the information. There are a lot of data there. The response is Y, which is the percentage increase in the minute ventilation, which is given by vent in that actual data set. That is total volume of air breathed by per minute by this bird. Potential predictors are X1 and X2. X1 is the percentage of oxygen in the air and the baby birds breathe in, and X2 is the percentage of carbon dioxide in the air the baby birds breathe out. So, based on that, the model is proposed here. We have not found out beta 1, beta 2, we are going to find out, but first the model, I will highlight it. So, you have actually y1 is equal to beta naught, which is the intercept. Beta 1 is the regression coefficient with respect to x1, which is the first random variable, which is here, which I will put the tick mark with a different color. So, x1 is here. And similarly, x2 is given by percent of carbon dioxide in the air the baby birds breathe out, breathe depending on how they are intaking. There are in total 120 data points, and you have the error term also epsilon. Now, the actual analysis of variance, because all this information of R, R square, total sum of errors, SST, SSE, SSR, degrees of freedom, everything is plotted in this table. I would not go into the last two column which I am marking in violet color, which is F value and P value. That we will take care in a simple formula later on for finding out the confidence interval of the fact of the betas. That will give us the idea of the concept of inference, which is interval estimation, and also these values of F and P, F distribution, P values, they would give us an idea of the hypothesis testing, which is a part and parcel of DADM1 course, which is there in NPTEL, which had been recorded and has been done from my side. So, if I consider regression as degrees of freedom 2, because x1 and x2, based on 120 data points, the adjusted sum of squares, the adjusted mean values are given in the first column, where I put a first tick mark. Then corresponding to adjusted sum of squares and adjusted mean square for the first random variable and the second random variable are given by where I put a green tick mark and then I put the orange tick mark. Then the error term, now if I find out the error term, it would be actually be based on the fact you have beta naught, beta 1, beta 2, 120 points, n, k is 3, 120 minus 3 is 117, that is highlighted here. And based on the lack of fit, how many points are out of the straight line? This is because it is a 3-dimension one, you will have x1 here along my right hand, x2 along my left hand, and y would be along the vertical direction. So, you will have a plane to fit it, which is the regression line in the 2-dimensional case. So, the pure error would basically be based on 100 points, total number is 119, which is 120 minus 1. Why 1? Because if you remember, in the value of R square adjusted, if you take SST and when you find out the adjusted, the SST has to be divided by n minus 1 to find out per unit reading. Similarly, SSE is divided by n minus k per unit reading. That means, on a per unit scale you want to find out the value of R square, which is called by as R square adjusted. Now, here is what the values are. If I use R square, the values which I put from the table for R square comes out to be 1 minus this value, that comes out to be about 0.2682, and R square adjusted corresponding to the fact that you have n minus k, n minus 1, that value comes out to be 0.26192. Now, the question would be actually the R adjusted value, if the variables have been actually taken properly, in the sense the right choice of variables. There is a huge body of studies for that in statistics. I am not going to go into the detail. Then R square adjusted should increase. Here it is, if I take the 2 decimal places, it is 0.26, 0.26, which is fine. But for more than 2 decimal places, R square adjusted is decreasing, which technically should not be there, but I wanted to show you that example that there can be problems where you find out the R square, find out the adjusted R square, but the R square adjusted value may decrease. So, obviously, do not think that R square adjusted problems would be there, not there, but which means that the choice of variables based on which you are doing that study have to be found out. The best set of random variables x1, x2, x3 have to be found out such that the best fit is possible in regression model. Based on the simple study, we have beta naught as plus 86. I should use a different color. 8 plus 86, beta 1 is minus 5.33, beta 2 is plus 31.10, and the corresponding values of standard error which you see here, they are actually, if you remember, the covariance of beta hat. So, in this case it will be of size 3 cross 3, and the corresponding standard error for beta naught is, if I take the square root, it becomes the square of standard error, which should be going in this place, square of that, remember not 106, square of that. So, that will go to position 1 comma 1. Similarly, in the position 2 comma 2, the square of this would be coming, that is because that is the variability for beta 1. And similarly, in 3 comma 3 place, the square of 4.79 would be coming, which is the variability of beta 2. And of the diagonal element, you will basically have, I will use a different color, say for example, green. So, this element would be exactly equal to this. That means 1 comma 2 and 2 comma 1 should be same, because that is the covariance of beta naught with beta 1 or the covariance of beta 1 with beta naught. Similarly, if I consider these 2 elements, I am marking with different color, which is in position 1 comma 3, 3 comma 1 is the covariance between beta 1, beta naught and beta 2. And the last factor, if I again use a different color, which is light blue, and the positions are in place of 2 comma 3 and 3 comma 2 are the corresponding covariance between beta 1 and beta 2. So, these standard errors is basically the standard deviation of the sample. Thus, the MLR for this form is as given. I will consider the dark blue. So, this is the equation 86 minus 5.33 x1 plus 31.10 x2 plus epsilon is the error. So, that is the best fit regression model which you have, based on the fact you are trying to minimize the ordinary least square errors, which you have already done. And when I plot it, now if this is a 2-dimensional figure, 3-dimensional figure. So, along this axis I am marking y could have also been done vertically, x1 is here and x2 is here. If I plot all the points, I have the scatter plots. I wanted to show you the scatter plots, and if I fit the best plane, consider you have x1 here, x2 here and y is here. The plane which you will have the best fit line is the one which we just found out, with beta naught hat, beta 1 hat, beta 2 hat. And the variability is the actual distance between each point which is plotted in this graph onto the plane. And we take that square of these errors, sum them up and then try to differentiate with respect to beta naught once, beta 1 another time and beta 2 the third time. 3 equations, 3 unknowns, solve them, that is what the actual crux of the model is, which we have been discussing for so many days in lectures. Now, we will do another problem. Data are a subsample of 500 observation. Here now here 500 observation. This is example number 27. From a data set that originate in the study where the interest is for air pollution at a road in related to traffic volume and meteorological variables collected by the Norwegian Public Road Administration. The response variable, which if you when you click onto the data set, you will find out in column 1 consists of hourly values of the logarithmic of the concentration of NO2 nitrogen dioxide particles measured at Elnarbro in Oslo between October 2001 to August 2003. So, the actual random variable which you are going to study, which y, is ln of NO2 concentration particles. The predictor variables column 2 to 8, which is 7 in number, are logarithm. So, the first one is the logarithmic of car numbers per hour going through that place, temperature 2 meters above ground from the level in degrees centigrade, wind speed meter per second. The next one is temperature difference between heights of 2 and 25 meters above ground, the wind direction being measured from 0 to 360, hour of the day and the day number which is given. Again, the data can be found at Carnegie Mellon University statistical data, which also has a lot of data set, and the write up can be found out as given in this link. So, now before we go there, I will just discuss the problem in some details. Now, if you remember, in many of the models we have been discussing that the value of y is as given or x is as given. But remember, I always mentioned in the assumptions that be very careful that all the x's are normally distributed with a mean and variance. They should be independent of each other. Next one is the error terms is normally distributed with 0 mean and a certain variance sigma square. And third fact is the errors do not affect x, neither the x values affect the error term. These are very important. And the concept of homoscedasticity, heteroscedasticity, autocorrelation, non-autocorrelation was mentioned time and again in the earlier problems. I am again mentioning that. Now, what is the reason I am mentioning? The reason I am mentioning is that as you basically get the data, do not jump in and try to utilize multiple linear regression or simple linear regression model. I had given a important point very briefly that you should do the statistical test, which I am not going to cover in this regression models because there are a lot of things to cover, that you should test that all the x values are normally distributed, which is with some transformation, mathematical transformation is possible. What may be difficult is that to find out the correlation coefficient or the covariance or the relationship between the x being 0, that means they do not affect each other, may be difficult to find out. So, you have to do some extra statistical studies. Again, I am skipping for the time being. Now, when you do that, at least the first part, how to convert into normal distribution, many type of mathematical simple transformation are used. Some is that best would be that you convert x values or y values, whatever it is, into the logarithmic form. And in many of the cases, converting them into the logarithmic form actually gives you the distribution of either x and y as normal. So, with this I will end this class, but I will carry forward this problem in the next class as there is this continuity. So, whatever I mentioned, you listen to that, and with these 2 slides which I have discussed, we will carry forward in the next class and continue discussing the solution of the problem. Thank you very much and have a nice day.